All right, for the last part of this chapter, I've combined them into one set of lectures. 17.10 just looks at logarithms that are all nice clean numbers. So like if I have 1.0 times 10 to the negative third, the negative log of 1.0 times 10 to the negative third is 3.00. Okay, and then 17.11 is where we start looking at if I have something like 1.32 times 10 to the negative fourth or something. Okay, obviously that's not as clean of a number, and I need to use my calculator for that. So let's see here, my negative log of 1.32 times 10 to the negative fourth is 3.88. Okay, so what we're doing is we're looking at the pH scale. So we've got different ways we can measure pH. We can use indicator solution. We can use indicator paper where we compare to a color and we can get an approximate pH, or we can use a pH meter and we can get a nice exact pH. Okay. What's interesting is the pH meter is actually an electrochemical sensor. In our pH scale, if we have a pH of 7, it's neutral. Greater than 7 is basic, and less than 7 is acidic. This is because we're looking at negative logs. Okay, so it's a negative logarithmic scale, so that's why less than 7 is acidic. So again, here's a pH meter, here's some pH paper. This is a cabbage juice indicator, which is an indicator you can actually make at home that will help you approximate pH pretty well as well. Okay, when we look at our pH scale, okay, we have two calculations we can use, pH or pOH. We usually use pH versus pOH. The reason why we do these P numbers is because we're usually thinking about things that are in a really, really small amount. And so when I think of a pH of 3.2, that's much easier than thinking about a concentration of something times 10 to the negative fourth. Okay, so we use the P numbers, and they are negative logs. If you can think about a really common logarithmic scale is the Richter scale. All right, which we use for earthquakes. So a magnitude 4 earthquake versus a magnitude 5 earthquake. Now the Richter scale is a positive logarithmic scale. So we're going to get worse on our earthquakes when we go up. Now what's not mentioned here when we do this negative log that's implied is it's a log base 10. So each time I change a number, I am 10 orders of magnitude different. So my Richter scale again was a positive log. Okay, so a magnitude 3 earthquake versus a magnitude 4 earthquake. That magnitude 4 earthquake is 10 times the strength of the magnitude 3. The magnitude 5 is 100 times the strength of a magnitude 3. So when I look at, say, a pH of 1 versus a pH of 4, okay, well, that pH of 1 is 1,000 times more acidic than the pH of 4. Because again, it's a negative logarithmic scale, so I'm getting more acidic as I go down. Okay, the pH of 3 is 10 times more acidic than the pH of 4. pH of 2, 100 times more acidic. And again, pH of 1, 1,000 times more acidic than that pH of 4. So here's a bunch of substances. Let's see if we can classify them as acidic, basic, or neutral. Well, the egg white with a pH of 7.9 is basic. Maple syrup, 7.0 is neutral. 3.8 is acidic. Sour milk, acidic. Lime juice, acidic. And tomato juice is acidic. Out of all of these, which one's the most acidic? If you said the lime juice, you were correct.